All right, guys, let's jump into our series, Metabolic Homeostasis. I want to do a quick review of last week for those who may not have seen that one. And it was precipitated by a client who simply asked me a question, like, have you heard of this guy, this book? One of our colleagues was talking about it, and I discovered that an evolutionary anthropology professor had written a book, kind of a pop culture diet book called Burn. And it had a lot of pretty lofty promises of teaching us all the things we have made mistakes about regarding metabolism, and promise to show us, the right way to lose body fat. Getting through all of that stuff, the couple premise points that I think could be misconstrued, and maybe just through the publishing process in genre, not genre fiction, but maybe genre nonfiction. He basically comes down to the point, because he had done some work with the Hadza tribe in Tanzania, and said that, hey man, look at all these people over here who walk 20,000 steps a day, and they're super active, primitive hunter-gatherers. They are expending so many more calories than us that you would expect them to have super high metabolic rates. And with metabolic cart testing and so forth, they just did not. And so therefore, homeostasis must kick in, and it just doesn't matter, is kind of the end result when it comes to exercise. Don't exercise, walk 20,000 steps, do 4 hours on the treadmill. Your body is going to adjust metabolically, and you will just drive your metabolism down, and you will simply not lose weight. The problems with that are, first of all, he has some things that are actually very right, and that's what we're going to talk about today. We're going to go through some biochemistry. What is wrong is that he's just kind of looking at the wrong end of the horse, because what he should have told people, and this is going to be a major reinforcing point that I discussed today, is that you should want a slow metabolism. You should be so healthy, like those hunter-gatherers, that your resting heart rate is incredibly low, and that the tens of trillions of cells in your body have such slower metabolic demands that they age more slowly, because that is the essence of longevity, that you are so lean and healthy that your resting heart rate is lower, your cellular metabolic rate is lower collectively. That's a good thing. That just kind of got lost in all of the publishing hype. So we're going to go through some of that today, because the other thing that he got right is, no, you shouldn't be doing, a dozen hours on the treadmill every day trying to lose weight. Because of homeostasis, you're probably going to drive hunger cues even higher. And just through observational study, as his was with the Tanzanians, you're probably just going to eat more. And therefore, are you going to lose weight any faster? Maybe not. If you controlled everything to the nth degree, if you were tracking food and maintaining an appropriate calorie balance, maybe you are expending more calories. Maybe your calories do come up a little bit, but not that much to completely mitigate the deficit. Then his premise would be wrong. You still could choose to exercise more and eat a little bit more, or keep your food the same and just kind of gut out the hunger. So anyway, it was a weird conclusion, but he did at least open up this point that your body does self-regulate some processes, and that's what this is all about. So let's get into some of the nuts and bolts, because again, last week was a little bit more about just looking at his conjectures, what he was trying to get across this book, because he's doing a lot of interviews and so forth, and it may become a little bit of a phenomena in terms of what people are talking about. And then, as we see so often, people take a little nugget of truth and run to such an extreme that becomes pretty harmful. So I've got 3 or 4 studies that I looked at, and as I was telling Kevin off camera, this just kind of led me in a place that I didn't expect to go. I was really looking for practical application points, and I kept running into some very interesting things that I thought could help some of you just understand how this even works. And I'm gonna before I get into some of the more technical things, because I really do plan on glossing over them and just giving some high points, I want to give you a kind of a framework to think through first. So if we build this little filter on how to think, it may help. So as I mentioned, with successful longevity and decreasing metabolic processes to the point where we're aging more slowly, think of it also from the side of abundance or scarcity when it comes to nutrition. When we have too much food, what does our body do and why? When we have too little food, what does our body do and why? One of the things I was also just talking about off camera, I think it was off camera, was Dr. Robert Sapolsky just had a new book come out, and he is a professor at Stanford, retired now, but he's named in 4 or 5 different departments as he's a professor of neurosurgery, a professor of ophthalmology, a professor of neurobiochemistry, of primatology. He was actually awarded, is it the MacArthur Genius Foundation Award? He's one of the best science communicators of this generation. And one of the funny things he said, just completely off topic, his new book is called Determined, and the whole topic is determinism versus free will, more of a consciousness thing. And he was quoting somebody, and he said consciousness is in well, what did he say? And I'm going to forget it. It's an inadvertent hiccup. I think he was quoting Noam Chomsky. Like consciousness is a superficial thing. We think it's the thing, but it's, our body has these biological drives starting from our brain stem, most primitive part of our brain, moving forward into the cerebral cortex. And what we think and what we feel just doesn't matter. What our body is always trying to do is simply survive. So think of that as the filter. Even something like a hunger cue isn't just for you to feel good or feel, not good because you're in a calorie deficit. It's your body's prompt to try to make you eat. So we're going to go through some of these processes just to show you how that works, because I always have the premise that if you can understand some of these things, then I think your connection to them cognitively can be very helpful, instead of just blindly feeling something and then acting impulsively or as a reaction. You can say, oh, okay, this is what's happening. I now have a chance to cognitively control my reaction to it. So I really don't want to get into a ton of detail about some of these things. Primarily, matter of fact, I want to show you just the fact that there is this entire field of study on metabolic homeostasis. So not just a phrase that I picked out of the air, and through even different chemicals, substrates, neurotransmitters, signaling agents, and so forth. You can get into more and more applicable stuff, which was my intent today. So because there are some of these chemicals that are going to come up as we go through it, I want to keep coming back to what's really happening in the body. So this one was very, very interesting. This is an article that is less of a study and more of a report of findings. So adipose tissue expandability in the maintenance of metabolic homeostasis. This was some new information to me. I think you guys are going to find this interesting. So you know what adipose tissue is. If you've ever looked, I guess I should have put in a couple pictures here, kind of a slide of what adipose tissues, fat cells look like. I always have taught they kind of look like little bunches of grapes. Like they are literally just sacs. Oh, Kevin's going to do his thing. You're looking some up, aren't you? And so you look at these little vassals that contain oil. That's what fatty acids, triglycerides are. And those adipose cells can increase. Like if I gain 20 pounds of body fat, those are going to increase. But there is an incredible differentiation that I want to talk about here, because this report brought it up. So increased adipose tissue mass and adipose size occurs in obesity. So again, those body fat cells are growing. The obese condition is a risk factor for development of insulin resistance, diabetes, blah, 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 blah. However, the observation that some morbidly obese individuals maintain normal glucose tolerance, where some mildly overweight individuals become severely insulin resistant, suggests that it is not the absolute amount of fat that determines insulin resistance, but rather where the fat accumulates in the function of the adipose site itself. Thank you, Kevin. So there you go. Look, so first of all, that is, those yellow things would be the body fat cells where we're storing that. And then you see there is vascular tissue there. As we found out a couple weeks ago, there are hormones and signaling agents that are communicating that fat is a living organism collectively. It's not just an inert, storage site. But here's what's really, really cool. I think I might have, maybe I did not. Anyway, I was going to think if I showed a picture here. The extreme opposite example that demonstrates the necessity of adipose tissue in the maintenance of metabolic homeostasis is the lipidystrophic state. And that is a severe reduction in adipose tissue. This is kind of a pathology. And what they were showing here is that you can have more body fat than anybody else and actually not be that much at risk for metabolic syndrome symptoms, type 2 diabetes, and so forth. And then other people who may not have the structural ability to grow what they call safe body fat storage sites, they end up having a leaner body, but they suffer more from health. So again, the simple mechanism that it's not necessarily just the total amount of body fat on our body, but how and where we store it. So when the amount of energy entering the body exceeds the amount of energy being expended, the excess energy is usually stored in the form of triglyceride and adipose tissue. The mature adipose sites present within the adipose tissue, expand as they take up lipid from circulation. So additionally, as storage demands increase, pre-adipose sites present within the adipose tissue differentiate and become mature adipose sites. So we have these fat cells, and some of them are kind of on cue, almost as kind of a stem cell kind of phenomena. And then when they need to be called into action, then they can store it. Eventually, you end up with as many body fat cells as you genetically can have, and they're all growing and they are all full. What they found is that the actual storage capacity for fat is different in different people. And I'm going by memory here on studies, long ago in fat storage, that hyperplasia of fat cells can even occur if you have super rapid fat gain and so forth. But in a state of overnutrition, the adipose tissue is challenged to accommodate excess lipid. When the maximum capacity of adipose tissue expansion is reached, spillover of lipid from the adipocyte occurs, increasing circulating free fatty acids and the accumulation of lipid in non-adipose tissue. So skipping down a little bit to tissues such as the liver, skeletal muscle, beta cells, and the heart, which is harmful for metabolic processes, and it increases a state of lipotoxicity. So I'm going to stop here and give you just a little bit of a visual on this, because if you are somebody who's got some physiology background, or you have heard of like fat accumulation, fatty liver. There is something called the greater omentum, which is kind of a fat storage pouch that instead of it just being subcutaneous fat, it's under our abdominal wall. So it kind of impedes organ function. But we can also literally, as they said here, have fat that just starts to cake around our heart, even inside of our brain. And it turns out, with some of the research they did here, that is truly the harmful fat. When you have fat that accumulates just in these adipose tissue storage units, the adipocytes, it's technically not that bad. If that's the only place you ever stored fat, you could end up being pretty healthy and live a normal life. So one of the points I'm going to get here to eventually, but I want to mention it now, is that one of the ways you do that is by having a pretty high oxidative process of energy turnover, meaning you actually just exercise more. You're more active. And so it gets into the whole phenomena of, can you be, quote, healthy at any size? And we already know that somebody who is moderately overweight or perhaps even obese, but they exercise a ton, they are truly metabolically healthier than somebody who's lean yet doesn't exercise. And so that this is a check mark in that column for the fact that the process of how we store fat is related to our activity level and so forth, and how we eat, even things like how fast we gain body fat. So tying that back into our topic at hand, which is metabolic homeostasis, we're going to get to the point next week where we talk about what you truly can do. What does this mean? Can we, because our goal should be to actually have a slow metabolism, because that improves longevity. What's a healthy metabolism? How do we choose to use excess calories while still understanding that the goal should be, and ultimately will be in your healthiest state, that you have a slower metabolism? First, contrary kind of to what we discussed last week with this evolutionary anthropologist who said, don't worry about exercise for fat loss. Don't worry about it for fat gain. Just, it's all about food consumption. That's where the gold mine is if you're trying to create your best health from a fat perspective. But then out of the other side of his mouth, he said, but you should still exercise and move because there are other benefits to that, just not for fat loss. And that was one of my main couple of contentions. And here's where we can kind of agree, but I think he also misses this point, where how we choose to create that calorie deficit or calorie maintenance balance, just energy balance, it really does matter how it is. And so exercise and movement will help decrease lipid toxicity. Even if you have a lot of lipids stored in your body, movement is still important for that reason. Let me see if there's anything here. So several transgenic animal models with increased oxidative capacity show improved metabolic homeostasis, likely due to reduction of ectopically stored lipid. It has also been suggested that triglycerides themselves are inert lipid species that safely store fat. Lipid intermediates such as blah, 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 blah. Let me get down here to this. It has been proposed that these lipid intermediates mediate lipotoxic induced insulin resistance. So like I was saying, even just the fact that because you are avoiding those non-adipocyte type storage phenomena in your body, it's going to help you with the toxicity that even goes into our series we did on anti-inflammatory nutrition and lifestyle. So based on the hypothesis that the accumulation of lipid species within non-adipose tissue is detrimental to metabolic homeostasis, the prevention of lipid accumulation through decreased energy intake, increased energy expenditure, or increased lipid storage capacity of adipose tissue could prevent ectopic lipid accumulation, thus preserving metabolic homeostasis and preventing insulin resistance. So I'm gonna skip on. Well, actually, I did have one more thing to show you here. Homeostasis again. I didn't realize it was only the 1990s where leptin was identified as a gut neural axis mediator here. But the fact that we talked again in our series on fat, that lipid released from expanding adipocytes acts centrally to reduce appetite and increase energy expenditure. This is what I wanted to get to, and I have another study that kind of brushes up against this a little bit more completely. That your body trying to get to that state of balance of homeostasis, it has a couple agendas. One is survival, meaning we're much more prone to want to store energy because that's always the problem of our species classically, traditionally through our evolutionary development, is trying to deal with scarcity and starvation. But at the same time, these hormones are there to handle both sides of that equation. So from that adipose tissue perspective, leptin is one of those hormones that does help to drive or mediate hunger, depending on if it's circulating in high or low amounts. Increased adiposity is accompanied by increased circulating leptin concentrations. So why then does the obese state persist? In obesity, although leptin release is increased from hypertrophic adipocytes, resistance to leptin signaling develops, thus preventing a reduction in energy intake and depletion of adipose tissue. So again, you see how survival and the drive for homeostasis leads us to one thing, but when we go too far into a pathological state, that system breaks down. So here, leptin's goal is to make sure it's controlling hunger, and we are increasing when we have an abundance of adipose tissue. We have been accumulating stored body fat, so our bodies from a morphology perspective aren't hungry. We don't need more food. Leptin is circulating to dampen hunger signals, so we shouldn't be hungry, but we still get hungry because our receptor sites start to desensitize. And also, as Dr. Sapolsky in his new book Determined states, he picks out something like this: the fact that there are even little epigenetic mechanisms that just simply make us more prone to hunger and obesity than other people. And he even mentioned a difference in leptin receptor mutations. And he gave this example. And this is so the point to that, before I forget, is that we just have different genetics that make us prone to be overweight or underweight because of some of these phenomena. So he mentioned the difference between a mountain vole and a prairie vole. These are indistinguishable animals. They're basically rodents. And yet, one of these species are completely pair bonded monogamous, and the other ones are not. And it's like, well, how, like, what was there something just, in their environmental evolution that created this difference? Is there anthropology at play here? And they found out, no, it was just on the epigenetic receptor site of vasopressin, a hormone that drives sex drive and so forth. There was just a mutation difference at some point, just like we mutated, humans at some point had, I think, just all brown eyes, and blue eyes was like a mutation or something like that. At some point, there was this mutation, and it just completely changed the, quote, sexual appetite of the voles. And so now they're almost, even though they're the same species, they behave entirely differently. And very similarly with us, in something as simple as leptin, which controls hunger, some humans just perceive hunger entirely differently. So again, something that from his book Determined shows that you don't really get much of a choice in that. Like you're dealing with the hand that you're dealt. But coming back to just, why does this matter to us in terms of metabolism and understanding of it? Although we know that obesity is a major health concern that predisposes individuals to many secondary conditions, including insulin resistance and type 2 diabetes, we suggest that it is not the absolute amount of adipose tissue that determines the metabolic disruption, but rather the limited expansion capacity of the adipose tissue. Identifying adipose tissue expandability is an important factor in preventing lipotoxicity and associated metabolic complications that may introduce new therapeutic approaches that promote adipose tissue storage capacity. So isn't this funny? In a way to save lives, pharmacologically, it may be one day the goal to increase your body fat, that we have better adipose tissue expandability so that we don't have to experience that spillover that creates lipid storage in organs like your liver and your heart. That's a weird thing to contemplate. I don't necessarily think that's anybody's goal, but it shows once again that the body's drive for homeostasis is not necessarily how we perceive it to be. Our drive is to look great and feel great. That's what we want, and live forever. Not exactly in line with the body. So you can't talk about metabolism without talking about mTOR. And I almost said I was going to skip over some of this stuff, but once again, I just want you to be aware of what is here and how many chemical mediators are at play to drive something as simple as we think of as maybe metabolism or hunger. So the mammalian target of rapamycin, mTOR, couples a variety of different environmental signals, including nutrients and hormones, with the regulation of several energy-demanding cellular functions, spanning from protein and lipid synthesis to mitochondrial activity and cytoskeleton dynamics. mTOR forms two distinct protein complexes, mTOR-C1, mTOR-C2. This review focuses on recent advances made in understanding of the roles played by these two complexes in the regulation of whole body metabolic homeostasis. One of the things that this is important for, because if you go all the way back to like the 80s and the 90s, it was very common for people to talk about anabolism versus catabolism. Your body is either expending energy in a state of depletion, or from a process standpoint, in a state of abundance and growth. And a lot of times we think of it as just body fat storage or not. The body doesn't. Like that is entirely secondary to what the body's goal is. mTOR is something that drives even protein synthesis. So for building muscle, for just growth and development, through puberty and the rapid growth of your first year of life and so forth. So these two, mTOR, these two opposing complexes within the mTOR are simply there for either, promoting catabolism or anabolism. And in a state of anabolism, you're probably in a calorie surplus enough that you're not only promoting growth of lean tissue, but also the accumulation of body fat. So studies carried out in the last few years have shown that mTOR-C1 activity in the hypothalamus varies by cell and stimulus type. Again, epigenetics could be very different person to person, and that this complex is critically implicated in the regulation of food intake and body weight, and in the central actions of both nutrients and hormones such as leptin, ghrelin, triioditherone, or onine, as a regulator of cellular anabolic processes, and even down to adipogenesis, lipogenesis, and so forth, which again is either gaining weight or losing weight, gaining muscle, losing muscle, gaining body fat or losing body fat. So mTOR-C1 and the CNS regulation of energy balance focus on the action of hormones. Within the central nervous system, the hypothalamus is a key regulator of whole body metabolic homeostasis because of its ability to integrate nutrient and hormonal cues and adjust food intake and peripheral metabolism in response to energy availability. And that, of course, is primarily driven through hunger. So this is where I'm going to skip through a couple things, but I do want to show you the high points. How this one simple duality of one signaling agent is going to affect energy balance, whether we're high or low in calories, and how your body's going to adjust that. The regulation of glucose metabolism, and on the next slide, lipid metabolism. These again are signaling agents that are prompting you what to do, your behavior. Are you hungry or are you sated? What are you going to do? But then it's also driving chemical processes to either store or liberate these nutrients. Not going to get into that. So here's what I want to finish with today. And then hopefully if you guys have any questions just on more of the practical application, we can kind of get a head start on next week. But let's do a little bit of a review of last week again and how it ties into this week, and a little bit of foreshadowing for next week. So we like to think we can control our metabolism. There is a lot of marketing information thrown at you that, oh, your metabolism is broken. Come to me, I can help you fix it. This way of eating is better for your metabolism. This way is not. It is so entirely driven, as I wanted to convey today, by your state of abundance or scarcity from an energy balance perspective, and therefore also your sustained behavior chronically. Because when the body does start to adapt, it's always going to be not in your favor for what you want for body fat loss. If you're successfully in a calorie deficit and coaches or programs or books are promising you that we can grow your metabolism, expand your metabolism while you lose weight, that doesn't happen. or we can prevent it from slowing down. That doesn't happen. You should actually want that because that's a good thing for longevity, and it's just going to happen anyway. What you want to avoid is undue suppressive adaptation, meaning, and this is very difficult. I'm going to go back to a study I looked at 20 some years ago, and it was the fact that you need to be on a very low calorie diet medically descriptioned or prescribed of about 500 calories or less for a minimum of 8 to 12 weeks before you start to see your metabolism reduce pathologically beyond what you would see normal metabolic adaptation. And who does that? I mean, who consumes fewer than 500 calories a day consistently, never a binge, never an increase, never a piece of birthday cake, just to end up in that sustained suppressed metabolic state? It does happen, usually not of our own accord, if you are starved for some reason, circumstantially or oppressively. But the vast majority of people just never have to worry about that. We're going to choose a certain dietary device to get us to a calorie deficit and hopefully to a better state of health, loss of body fat. But along with that comes normal metabolic adaptation. There are some things we'll talk about next week where we can at least identify what are those normal parameters. What is the norm? Is there any way circumstantially to mitigate that and still be healthy? Like when I am super lean and healthy, what can I do? Of course, it is being super active, exercising, not over exercising. I shouldn't said super, but you also are going to be looking at things like, are you consuming enough protein? Just, minimum RDA to, higher agency standards for that. Sleep is really big, those kinds of things. So coming all the way back to just catabolism versus anabolism, there are things we can do behaviorally, but all of this to say that much of what the pop culture, diet, media, and marketing information would lead you to believe, you can't just control your metabolism or eat a certain way and raise it. It is very, very homeostatically driven, way beyond your control, very genetic and epigenetically driven. And I think, as I started out with, if you just understand these things and how it works and what's normal and what's not, it should give you a lot more ease as to what you can expect and the kind of pathway that you can expect. So let me stop there and let me open it up to you guys. By the way, this is what we're going to look at next week. When you see applied physiology, applied meaning we get to do something with that. That's going to be a little more fun for us next week, I hope. So I'm going to stop the share. You guys feel free to jump in. Of course, deferring to Dr. Souders if you have some good points here, Jennifer.
Not sure I really have anything specific to add to this. It's been a recognized thing that what we call visceral body fat is certainly the most negative type of body fat that we have. It's the higher the level of visceral body fat, the higher level of not only inflammation, which is one of the things that drives, but the associated negative hormonal effects of that. So I'm not sure I have anything else really to add.
Yeah, what was new to me on that is the fact that I always thought you just get one with the other, and that's what's happening.
No, and in fact, it's kind of interesting because there is some genetic link to it. I know in medicine, Kevin can probably speak to this as well, but we're generally aware that certain racial ethnic groups, like particularly comes to mind as Asian folks, may have less of the adiposity that we would see as subcutaneous, and they may look healthy on the outside, but they may be carrying a higher propensity to, a higher amount of and have a higher propensity for storage of visceral body fat. And I think that that's got to be at least somewhat genetic, although it also may be environmental. Kevin, you may have even better perspective on this than I.
I don't have too much to add to that. I think of Native Americans who are at high risk of just obesity itself, but I'm sure it's a little bit of both of environmental and genetics. It's hard to say which one is the prize here.
Yeah, and the epigenetics are important too, because there is now, in particular, I think it started in the Native American populations, which reminded me of this. But when you have adiposity in a pregnant female, that the epigenetic changes can start to present in the fetus, while they're still in utero and before they're born. And it basically programs how that person's adiposity is going to be before they've even had a moment to control their own food intake.
Which is why I can't wait to read Dr. Sapolsky's new book. I watched about 3 long interviews of his yesterday, and he even talked about the fact that, besides in utero, all those chemicals happening and so forth, dictating how your brain even begins to develop. But one that was very interesting, he cited a study that's kind of a new version of the Stanford marshmallow study, in that they would put people down, people who were, let's say, dieting, calorie deficit, and put them down in front of a bowl of M&Ms. And they'd be like, you can eat these if you want, AKA the, marshmallow study. But we know you don't want to, so you don't have to. And they gave them problems to solve and so forth. And they psychologically introduced stress. And the more stress people encountered, the more they started eating. And so even something like cortisol and again, environmental, you could get into the social, the socioeconomic status of individuals, and why sometimes poorer people, under-resourced people, just have higher risk of health malady are those reasons. I mean, it's just they are facing that kind of stress on a minute-to-minute basis that not everybody does. And that drives some of those hunger cues, because also, like we talked about last week, that fight or flight response where you're constantly releasing glucose into the bloodstream and liberating triglycerides into the bloodstream, that increases this kind of cytotoxicity, this kind of lipotoxicity, because you're constantly from that visceral area of your body. That's where you're introducing this energy balance exchange to lose and restore. Happens a lot with your liver and gluconeogenesis. And so somebody who's constantly under stress, even if it's self-induced ourselves because of our personality traits and how we deal with anxiety, it can be doing this. Like, you could be driving yourself into rates of lipotoxicity that's not even that related to your body composition. You may not even be that overweight, and you could be suffering those kind of lipotoxic extremes just because of your mental state.
And glucose tolerance. In fact, yeah, I listened to a podcast yesterday with Eric Topol and Peter Attia, and they were talking about, Peter Attia has a lot of his patients on continuous glucose monitoring so that they understand how their blood sugar responds to their lives. And one of the big points he brought up was the terrible glucose tolerance when you're sleep deprived, and that and sleep deprivation can result from so many different factors, right? And stress is either chicken or the egg thing, right? Stress can cause you to lose sleep. Losing sleep causes stress. So those are other factors too that really point into this whole complexity. It's so interwoven.
And here's how so much of this is within our control. And it's not what any of us want to hear, because we just want to be able to take a pill or eat the magic food or do something, and this is all taken care of. But if you really pull this down into the controllable variables, and like you just said, Jen, you're getting enough sleep, you're controlling anxiety and mindset, which can control systemic inflammation, and you're doing all of those things as a precursor to even trying to lose body fat. Now you're going to have a much more successful chance of losing that body fat, and that creates that upward spiral of what you're describing. I mean, I think of that study with the M&Ms, and to tell my clients, okay, you're all trying to hit these certain standards and do these things, and we're trying to be as accurate and objective as we can, and we want to be as scientific yet also just supportive and behaviorally adjacent. But if you're constantly under stress and you're constantly not getting enough sleep, this is just not going to work. On any level, this is not going to work. And so you have to focus on those things at the same time.
Yeah.
Don, you have not been here for a while. Anything that jumps out at you from this neural behavioral perspective and what can happen internally with fat storage? And if you can't talk, if you're driving or something, feel free to just ignore me. There he is.
You're tough to ignore. Can you hear me?
I am. I can.
Oh, okay. All right. Yeah. No. Nothing to add. It was a great roundup. I love it. Looking forward to next week. No, it's I may have some comments next week though.
Okay, good. I'll try and find some things that are definitely practical for us.
Yeah, it's great. Thank you so much.
All right, good to have you here. Kate, did you have a question?
I do have a question. If you get to the point where you have a lot of visceral fat, does it go away? Like once you start to lose weight and start to lose fat, in what order? I mean, is that the first fat to go or is it the last fat to go?
It is a little bit more driven by activity. So that's important. And that's, one of the reasons even before today, I just really value movement as part of our health, the orthopedic health, the metabolic health. And so typically I think you do see a little bit more visceral fat in men, and that's, kind of driven by testosterone and that kind of thing. But I'll give you an interesting little story. Just it doesn't really answer your question, but I hope it scares you into just wanting to stay lean and healthy. When I was an undergraduate, I was selected to be on a small team to prosect cadavers for the graduate students. And then when I was in physical therapy school, we got to dissect, more cadavers and so forth. And in a very meaningful way, I hope everybody here, like, you're all organ donors and you consider donating your body to science and that sort of thing, because it is so important for, people in the medical field. But I will never forget. I mean, you literally almost feel like you build relationships with these people who have donated their bodies to science, because, you're working with them, you're working on them, you're doing all this stuff as a way to learn yourself and for other students to learn. And one of my cadavers was a very large man, obese. I'm going to guess like 6 feet tall, 300 pounds. And having already dissected a couple more normal sized cadavers, when we got to this guy's chest wall and we, went in to extract the heart, I started thinking like, man, like something is just not right. Like, where is the heart? I expected, like, even if there was visceral fat, I expected there to be a layer of fat. And then voila, there's this nice heart like you see in textbooks. His entire heart was the size of a basketball, and it was just encased in marbled fat. It did not look like a heart. It was just, you could not even get the fat off of the heart. It was just strangling it. And then even when we went into his cranium to extract his brain, very similarly, it's like this brain just doesn't look like the other cadaver's brains. And it was because there was just so much fat tissue, in, the sulcus and gyrus, type, ripples of the brain and so forth. And it's like, wow, like, I just wished at that moment, like, people could see the effects of taking care of themselves versus not. So that kind of visceral fat, Kate, it is dominantly utilized more by being active and so forth. And I think, as Jen was describing in Dr. Atiya's podcast, stress and that cortisol, fight or flight repetition, that's going to help pack that in. And so for you to decrease that from storage in the first place will help. But in general, if you lost 50 pounds, you're still going to lose a lot of body fat. You know, the greater momentum, visceral fat, that's still going to come down. But if there's one thing you can do, it's going to be being a little bit more adrenaline based in your fat loss, meaning epinephrine, norepinephrine, the fat loss hormones that are stimulated and released through movement, not just calorie deficit.
I would just add that I think, now this is in my recollection, but I know that Peter Attia does DEXA scans on a lot of his patients, and maybe all of them. And that my recollection too is from the literature, but I can't quote a specific source, but that, you know, if you track DEXA during a weight loss intervention, that the visceral fat is among the first of the fat stores to be liberated, because just because of the nature of the kind of fat, which is really fortunate. And that is, again, how people can potentially have a lot of adiposity that's subcutaneous, but be metabolically healthy because they're active. So I think that all does sort of go together. So the first thing to do for, you know, if somebody is overweight and, you know, or if they're concerned, there's nothing wrong with getting a DEXA scan, or, you know, even what is the other one that you can get, like one of my drugstore, I can't remember the name of it, the InBody, you know, that at least gives you something to track. And that can actually be very motivating for patients / clients who are wanting to do weight loss, if they can tell themselves that, yeah, maybe I can't see it in my belt, but I can see it on my scan, and I know that this is making me much healthier than one notch on my belt, that this is going down. I think that can help people psychologically as well as obviously physiologically. And I'm going to have to go, so just wanted to
Perfect, Jen. I appreciate that.
drop that in there. I've got another meeting coming up in 10 minutes.
All right, I appreciate it. And just to
Thanks. Have a great weekend, everybody.
You too, Jen. Just also through recollection, now that Jen prompted me in that direction, I wanted to say that the reason that visceral fat is more dynamic is because of its proximity. Like, it's right there around your liver in your abdominal cavity. And so because your liver is constantly moderating or monitoring blood sugar and blood lipids and amino acid and everything in your bloodstream, you know, that's more available just to its proximity. And so there are just better connections to that in the vascular system. So that is the good news. As Jen said, as soon as you start losing weight, you'll decrease, you know, some of that lipotoxicity from that. But let me end that here for you guys. The one thing I want to emphasize again, and I'll do it many times next week, is that we just have to start thinking about metabolism differently. That it's not something that is just controlled dynamically by us, to the extent through sleep and mindset and some of these processes that are directly related to that. Sure. But even that is minimum. Your genetics are your genetics and your metabolic capacity. And one of the things that we'll get into next week, the article that I have set up for next week, it talks a lot about metabolic set point. And that's what I want to really get into. That's another myth. And we talked about it in our metabolism research review prior. But you can't reset it as if you're giving yourself a DNA hardwiring and now you're becoming somebody else genetically. It's either underperforming or performing like it should. And you have to be doing some really disastrous things for it to be underperforming. Matter of fact, the heavier you are, the faster your metabolism is. So all of that just to try and get us out of the mindset of being a slave to some of that marketing information that bounces us from one thing to the next. When you're exercising, doing some resistance training, when you're getting enough protein, when you're getting enough sleep, when you have a long-term mindset arc of stability and less anxiety, that's it. That's the ball game. Your metabolism will be functioning as healthily as it can. And now it's a matter of just time, you know, and your consistency with metabolic positioning to get to your final goal. So we'll wrap up with some of that stuff next week, but appreciate you guys being here and hope you have a great rest of your weekend.